Now remember long time ago when we were reading information from the user, we said that sometimes the user might not enter the correct information. So we would get an exception. So let's say, for example, I ask the user for a number, okay? So I'll say int input, enter a number, okay? And let me just, all I want to do is just print this number. So if I run this program, I ask them for a number, they enter 10, things work fine. But if I ask them for a number and they say TEN, the program crashes. An exception happened. Why did an exception happen? Because I was expecting the user to give me an int and they didn't give me an int. They gave me a string which could not be converted to an int. So my program crashed. And so what we learned to do before was to say, let's try executing this code. So what I would do is I would say, try doing this. And if an exception happens, I say except. So in case an exception happens, I'll say, for example, you did not enter a number. Okay, so let's run it now. So again, if I just run it with the number 10, things work fine. But if I run it and I say TN, now it gracefully tells me you did not enter a number. So we were introduced to exceptions a while back. With files, exceptions can also happen. How can an exception happen? Well, let's say I ask the user for the name of the file. So I ask the user and I say, let's say file name equal input, enter file to read from. Okay, so I'm telling them, I want you to tell me the file that you're going to read from. And so they tell me, and what I'm going to do is I'm going to say fhandle in file equal to open. And I'm going to try to open this file for reading. And of course, I should always say .close, and maybe I just want to print the contents of the file. So I'm going to say print in file.read. So this will read the whole contents of the file and print it out. So if I run this code and I say enter pets.text, pets.text exists, so it works, it's fine. Just comment on. Now let me enter another file that doesn't exist. So, here, read from this file. Does this file exist? No. And so the program gives an exception. It gives an exception on line 10 when it was trying to open the file, and it says no such file or directory. So it tried going to that path, and either it didn't find the directory, like the folder that I told it to go to, or it didn't find the file. Either way, it didn't find the file to open. And so it throws an exception. So when we're dealing with files, we really need to catch exceptions. So when we're dealing with files, we should have like code that says try. So I'm going to try doing this. And if anything happens, I'm going to tell the user gracefully, sorry, I failed to open the file. So unable to open your file. And so now if I run this code, I enter some garbage, it tells me unable to open the file. So we can gracefully open a file and gracefully give an error message if I cannot find this file. Okay, so that's the first thing that we want to know, that when we're dealing with files, exceptions might happen. Okay, now I want you to look at the code on the next slide. We'll look at it together and try to think, is there any problem that can happen in this code? So here, we're asking the user for a number, we're asking the user for another number, and then we're trying to divide both. Well, we know one problem already that can happen is that the user can enter something that cannot be converted to an int. So that's one thing that might cause this code to break. Another thing that might cause this code to break is if the user enters a number in the denominator, num2 as 0. That will also give an exception. So here, if the user enters 10 for the first number and 0 for the second number, what I'm going to get is a division by 0 exception. So this is another exception that can happen. There are a lot of exceptions that can happen when we're running code. So what I could have done instead is to add a check to say if num2 is not 0, don't do the division. Tell them that I can't. Now, a lot of exceptions, like we said, can happen. Here, I'm trying to ask the user for how many hours they worked, convert it to an int and a float. And if the user enters, like, for the hourly rate, that letter P, well, the letter P cannot be converted to float. So this is going to give me another exception, a value error exception. So when we're dealing with exceptions, there are different exceptions that can happen. And sometimes when you're writing code, different exceptions, you might want to give a different error message for different exceptions. So what we want to learn is how can we deal with different exceptions and not just one exception. So what we did before was we just said try and except. And what this except did was it said if any exception happens, just issue this error message. Now let's look at the code above again, and let's see how we can make this code generate different exceptions. So here, let's say enter a number, and let's enter num2, just kind of like the slides. Input, enter a second number, and I'm going to print num divided by num2. And what I'm going to do is I'm going to copy this code out from the try so that it happens without any try, because I want to show you the different exceptions that are going to happen. Okay. Now here, when I run this code, the first exception that can happen is when I enter some garbage. I get a value error exception. So the value error exception happens when you try to call int or float on a value and that value is not convertible to an int or a float. In that case, you get a value error exception. The other exception that can happen is if I run and I give a 0 for the denominator. In that case, I'm going to get a 0 division error. Now, if I am writing the try except here, let's comment the top code out and run this code instead. Now, if I ran both of them, I say enter a number. If I enter like a bad value, it says you did not enter a number, which is right. Now, if I run it and I give 10 for the numerator and 0 for the denominator, it says you did not enter a number. And this is a misleading error message to the user. So I don't want to have an exception, an except clause that accepts all exceptions. I want to kind of decide the error message that I'm going to print based on the exception. So what I can do is I can write the name of the exception here. So if it's a value error, I'm going to tell them this message. And if the exception is and I forgot what it was, the 0 division. So what I'm going to do is I'm going to run that code, the bad code again, and see what the error message is, what the exception is. So let's run it again to see what the exception is, and it's complaining about line 23. Okay, so here I'm going to enter a 0, and the error is, the exception is called 0 division error. So that's the one I want, except 0 division error. So if I get a 0 division error, I'm going to tell them, for example, second number cannot be 0. So here, we are customizing the error message the user is going to be getting depending on what happened, what was wrong. So now if I run it and I give some garbage, I get the message you did not enter a number. And if I run it again and give a 0 for the denominator, I get a different error message that says second number cannot be 0. Now, what if like this code had also trying to read from a file? Let's say f handle equals open. And let's just open some garbage for reading. Okay. Let's see what happens when I run this code. I get another error, which is file not found error. Now, did I catch this exception? I didn't. So because I didn't catch this exception, when the exception happened, it came and it checked. Is it a value error? No, it's not a value error. Is it a zero division error? No, it's not a zero division error. So what I really should have done is added another clause to catch that file not found error. And in that case, I'll print a message that says error opening file for reading, for example. Now, if I run this code and I run it, it immediately tells me, oh, error opening the file because this file is not valid. Now, this is nice because you can customize the error message that you print out to the user based on the exception that can happen. Okay, so here is an example of some code. Here, I'm trying, the only error message that could really happen is the value error. So this is the only exception that I'm checking for. Here, I am opening the file, and I know that file can have problems, so I'm doing an IO error. IO error is a little bit more generic than file not found. It contains file not found and also like if a problem happens with reading. But you can, file not found is also fine. And then we saw that we can catch different exceptions just by doing except and specifying which one. Now, if I put some and I feel like, oh, I think more exceptions can happen from this code, what you can do is you can still put the except at the end that just says except, basically catch everything else. So if an exception happens, it's going to go and check the first one. Is it an IO error? If it is, it'll print the first message. If it's not, it's going to go check the second one. Is it a value error? And if it's not, it's going to check, print this message. And if it is, sorry, it's going to print this message. And if it's not, it's going to go to the last one. And so if you don't really want to specify specific error messages, you can just use the try except where it'll catch all errors. But here, the message is just so generic, it just says an error occurred. It's not telling the user what the issue is. This code, there could have been a problem opening the file. There could have been a problem converting a line to a float because here, for example, we forgot to maybe strip the line. So this code could actually generate either like a value error or a file not found error. Now, what if I am using an except and I want to print more information? So let's look here. When I had the code, can I undo? Nope, I can't. Let's do it again. So here, let's just put this code again at the top. And let's comment this code out. So let's say, so here, this error message that is getting printed has two parts. One part that just says value error, and the other part that says invalid literal for int with base 10 WFGGF. Now, if the user runs this code and they enter the first number correct and the second one bad, it tells me which part is bad, right? If I put this in a try except. By the way, try catch is for Java. Try except is for Python. Here I'm doing a try and I'm saying except print invalid number. Now, here the user knows that it's the second one because they got this message when they typed in the second one. But imagine if these were coming from a file. Here I'm just saying invalid number. I'm not telling the user which number is invalid. So if you want to print that error message that's coming by default from Python, what you can do is here add the word as error. What this is doing is going to be creating a variable that's going to be pointing to the error message. And then you can print that error message. Now here, if you have the value error, you can put it, but what if you want to catch all exceptions? What you can do is say exception. So exception is a keyword that refers to all exceptions, and say as error. And what this is going to do is going to save the error message, the exception, so that you can print it. So here what I'm going to do is I'm going to say except exception. And here it can be any variable. So I'm just going to say RRR, 4 R's. And what I'm going to do is I'm going to print RRRR. Now, here it printed that message that was coming next to the value error, and it's telling the user somehow that JSDFH was the value that had the wrong value. If I ran it and the first number was the one that I entered something bad for it, it would tell it. So this is nice if you're reading from a file and an exception happens. Let's say it's a file that's supposed to contain numbers and you ran into an issue where one of the lines was not a number. You can actually print out which line had the issue so the user can go and fix the issue and fix that problem. With the exception, it's, you know, when we learned it initially, we kind of learned it with the if-else statement. So here, this is saying try doing these statements. If it succeeds, if it doesn't succeed, if an exception happens, do the statements under the except. Now, what if no exception happened? You can have an else that says otherwise do these statements. So here an else will only execute if no problems happened. Let's look at an example. So here what I did was I put everything under my try. But instead what I can do is I can say if an exception happens, do this. Otherwise, go ahead and print num divided by num2. And so this line, I don't have to put it here. So if the code goes well and the numbers are fine, it's going to go and do the else. But if an exception happens, it goes and prints the error and it doesn't do the else. So it's kind of saying, try doing this. If an exception happens, run this code, otherwise run this code. So you can use an else with the except clause. Let's look at an example. Here what we're doing is we're trying to add some numbers that are in a file. So we initialize an accumulator to be 0. We try to open a file. So we go and we try to open the file for reading. And we make sure that we close the file. So we have our opening and our closing. And then we try to read the numbers. So we're going to go for every line in the file. We're going to take that line, convert it to a float, and save that in an amount variable. And then we're going to add that amount to total. So it's reading every number and adding it to total. What could go wrong here? Several things. We could not open the file. That's one problem that can happen. What's another problem that can happen? I read a line and I can't convert it to a float. So whatever exception here happens, what I'm saying is print me that exception and give me that error message that's coming from Python by default. If everything succeeds and no exceptions happen, then I'm going to print the total. So this this else clause will only happen if no exceptions occurred. If an exception occurs, it prints the error message. If no exception occurs and everything is good, then it's going to print the total formatted to 2 digits after the decimal. Okay, so that was it for exceptions. Now for the classwork for this for today, what I want you to do is you're going to modify the classwork that you did for 7.1. So you need to make sure you finish 7.1 first and get it to work. Now, I want you to handle the following exceptions. I want you to handle the exception if the user entered a value that's not a number. Handle the exception if the file cannot be created during writing. Let's say the user said created on the G drive and there's no G drive. And what I want you to do is I want you to print meaningful error messages to the user so that they can know what happened. Was it a number that they entered that was wrong? Or was the problem with the writing of the file? And so because 7.1 had 2 versions, the while loop and the for loop, if you saved them in different files, what you can do is just submit the for loop version with this code. Now submit your Python file and I want you to submit a screenshot of running your code and showing me the different error messages your code is printing when the user enters bad values. So you're going to have one for entering a non-numerical value, and you're going to have another screenshot for the user entering a bad path to a file.